All right, well, good evening, everyone. My name is Rachel Sanders, and I'm the volunteer program coordinator here at eCYBERMISSION. And today we have our very special guest, Will Doebler from NASA, and he is going to have his presentation, and he's going to talk all about his mission at NASA, what he's doing, how he's worked on it, and then we'll have a chance for you guys to answer any or ask any questions that he'll answer at the end. If you guys have any questions that pop up during this, you can drop them in the chat box and just make sure you address it to everyone and not just to Will or to me. And we'll go over this afterwards. All right, Will, the floor is yours.
All right. Thanks so much for the introduction and for having me today. Glad everyone could join tonight. Yeah, I'm Will Doebler from NASA Langley Research Center, and today I'll be talking about NASA's Quesst mission. But before I get to that, I'll give some background and info about myself and how I started working at NASA. Then I'll talk about acoustics at NASA, and some opportunities for students. And then finally, I'll go into detail about the NASA Quests mission. So first, a bit about me. My official title is Research Aerospace Engineer. I'm in the Structural Acoustics branch at NASA Langley, which is in the state of Virginia. I do research on sonic booms from supersonic planes, trying to make them quieter. I'm also working on my PhD in acoustics from Penn State, and I started working remotely recently from Minnesota. I had a bit of a winding journey to get to NASA. I grew up in a very musical family, and we spent a lot of time. I spent a lot of time playing French horn and band and orchestra. Did marching band, and I would go to band camp every summer. My love of music and physics got me interested in studying acoustics later on. And acoustics is the science of sound. In middle and high school, I had a good time in the Boy Scouts, camping and learning about leadership. The Boundary Waters canoe trip was probably my favorite. There was also the Space Exploration Merit Badge. That was fun. We got to launch model rockets. And I also enjoyed trying to make people laugh as a theater kid, and I did some video editing for the football team's highlight reel. I've always been a fan of the learn by doing model, so I would tinker with stuff in my free time. It's always fun to do silly projects like carve and assemble a pumpkin boombox for Halloween out of parts from Goodwill. And I like to fix broken paintball equipment, resell it, which taught me about electronics and air pneumatics. And I would do Lego robotics, which was my first introduction to computer programming. My pals and I there built an autonomous sumo wrestling robot called 4Chains because its drivetrain was connected by 4 chains. My first job was an ice cream scooper at Velvet Ice Cream, so shout out to the owners, the Brown family, for all their support. To get to NASA, some of my favorite classes were physics, computer science, math, and of course music. Python and MATLAB are the computer programming languages I use the most, and being able to use a computer effectively is really important. I'm excited to see how NASA will be using AI and machine learning in the future. For the NASA position I had, I needed to get a college and graduate degree. I went to undergrad at a small liberal arts college in Minnesota called Gustavus. I was a physics major, and I also spent a lot of time playing French horn in the music ensembles. I got a music minor and also did a Japanese studies minor. Research internships and experiences are pretty important resume lines for students these days, so I'd encourage you to apply for them. At Gustavus, I got to work in an ion trapping lab where we fired high-powered lasers at different metals and ceramics and then measured their properties with a mass spectrometer that we built. It's a top left photo there. And then later on in college, I was part of an ultrasound acoustics lab where our goal was to measure the force of ultrasound and to use ultrasound to detect cracks in jet turbine blades. Shout out to Dr. Patrica and Dr. Huber from Gustavus for helping me learn to do scientific research in college. And then after college, I spent one summer working as an intern in a Navy lab testing out different automatic speech recognition platforms for an augmented reality system. And after that, I started at Penn State in the acoustics program researching sonic booms. And I was fortunate that my advisor, Dr. Sparrow, sent me out to help with a NASA flight test where we recorded sonic booms, and I got to lay out microphones in the Mojave Desert in the hottest part of the day to measure the effect of turbulence on sonic boom loudness and variability. So my first official NASA photo is here with me with my eyes closed, shot out there in the desert. And then all the research that I was doing got me interested in flying myself. Did you know that you can get a pilot's license when you're just 16? There's probably a flight school at a small airport near you, but I learned during grad school in the Piper Tomahawk. You can kind of see the Penn State campus off the wing in the middle picture there. So I ended up applying for a NASA grad school fellowship, which was a really great experience. And I got to spend the summer at NASA Langley in the structural acoustics branch, where I heard that a job would be opening up soon. So after finishing my master's degree, I was lucky enough to get an interview and the job. And now I've been working there for about 6 years, supporting the NASA Commercial Supersonic Technology Project and the Quesst mission. So anyway, enough about me. Let's talk about some acoustics at NASA and some student opportunities. First, going back, what is acoustics? It's the science of sound, and it's a simplification of the fluid dynamics equations. There are many applications of acoustics, from designing instruments like the guitar animation shown here, to hearing science, building design, and even more. The project I work on for NASA is related to noise control. We want to make airplanes fly as quietly as possible so they don't disturb people from their daily lives. And learning about music and physics got me really excited to study acoustics. I'd like to also thank Dr. Russell from Penn State for these animations. NASA's divided into 5 different mission directorates: aeronautics, science, space technology, space operations, and exploration systems development. So NASA is typically, of course, associated with space research, and you might be thinking, hey, there's not a whole lot of sound in space. But the Aeronautics Research Mission Directorate focuses on several acoustics-related projects here on Earth for terrestrial aviation, like the X-59 Quesst mission that I support. I work over here in NASA Langley, which is in Hampton, Virginia, but there are many NASA centers across the country. My team regularly works with people from NASA Armstrong and Ames in California and NASA Glenn in Ohio. So most of these other NASA centers are focused more on the space side of things. At NASA Langley, we have two different acoustics branches, and you can check out their websites here for more information. The structural acoustics branch is the one I'm in, and it specializes in a number of things related to aircraft. First, psychoacoustics, which is the study of how people react to sound. And second, oralization, which is generating realistic sounds. We have 2 different dedicated lab spaces for playing back realistic aircraft sounds for people to listen to. One is focused on outdoor sound, the exterior effects room, and the other looks like your home living room, and it's for studying the effects of sound inside. We recruit people from the public to report their perception of the sounds, and we might ask them how annoying people find sound from real or concept aircraft. The branch also specializes in sound structure interactions, like how noise from helicopter blades interact with the helicopter body. And we have a team working on special liners that are placed inside jet turbines that reduce the noise. Our sister branch is the Aeroacoustics branch, and their research focuses on predicting noise from aircraft and finding ways to make them quieter. They test the performance of aircraft components in several different wind tunnels, and they also go out and make full-scale measurements or measurements of full-scale aircraft in the field. There are many opportunities for students at NASA. I encourage you to check out. The primary channels are through the intern.nasa.gov website and the federal job website, usajobs.gov. NASA internships are available throughout the year, either with fixed spring, summer, and fall sessions. And then there are some that have rolling admission deadlines. There are also some opportunities specifically for high school students and many for college and grad students. The intern.nasa.gov site also has information on available fellowships that you might want to consider to get paid while you're a grad student to do research. And the Pathways program is another cool opportunity. Pathways interns alternate between working at NASA and going to their respective college until they graduate. And then after completing the program, you can be converted to a full-time NASA employee. So that gives you a chance to transition directly to a full-time job without having to reapply. So definitely check these websites out as you move forward with your academic progress. All right, once you're on board, you might get to experience lots of unique facilities across NASA. At NASA Langley, there are a collection of really cool flight simulators. There's also the towering gantry facility where the Apollo astronauts trained, and it's now used for crash testing of air and spacecraft. There's plenty of wind tunnels to check out of varying size and speed, and maybe you'll find a virtual or a hybrid opportunity that's of interest to you. Maybe you'll be sitting at your your desk one day and your office mate will ask you to come help him instrument a wind tunnel with vibrometers. Or maybe you love noise reduction and want to contribute to quieter air transportation. So if psychoacoustics is of interest for you, we have the facilities for you to explore. Hope you'll check it out. All right, moving on now to the Quesst mission and starting with the background info. Did you know that supersonic flight is currently prohibited over land? Some aircraft are capable of flying above the speed of sound, but are not allowed to do so without special permission. NASA's vision is a future where fast air travel is broadly available to the traveling public. Future supersonic aircraft will fly over land without creating loud, disruptive sonic booms. They'll be efficient, affordable, and environmentally responsible, especially compared to older supersonic aircraft like the Concorde. The main barrier for this vision is the restriction on overland supersonic flight. So research agencies like NASA and policy agencies like the FAA play a central role in developing the data needed for new regulations that could enable commercial supersonic flight, and this can cut travel times in half. So what is the Quests mission? You know now that supersonic flight over land is prohibited, and the main goal of the Quests mission is actually to provide data from community noise annoyance surveys to noise regulators. The first step is to design a quiet supersonic aircraft. That's the X-59. The X indicates that it's an experimental aircraft, so feel free to look up other X-planes as there are many super cool ones. Step 2 then is to build the X-59, and this step is nearing completion. Step 3 is to fly it safely. Step 4 is to make sure that it's producing the sound that we expect and that we designed it to produce. Step 5 is to go out into communities and ask people about their perception of the sound. And step 6 is to provide data that we collect to support new noise regulations. And that's just the basics of it. There's lots of steps in between. We should probably take a step back and talk about what a sonic boom is. So a sonic boom is the pressure disturbance caused by an aircraft that's traveling faster than the speed of sound. And typically, a sonic boom sounds like a pair of fireworks going off within about 1/10 of a second of each other. So it's a boom, boom. And the two booms correspond to the buildup of pressure at the front of the aircraft and the release of pressure, the renormalization of the pressure at the rear of the aircraft. It's a little bit more complex than that, though, because very near the aircraft, you get this very spiky pressure signature. But as the waves propagate away from the plane, they merge into the two booms you hear. The merging is caused by what's known as nonlinear acoustics, where higher pressure waves travel faster than lower pressure waves. And the resulting pressure waveform is in the shape of an N. We call it an N wave. And booms that can be perceived louder, they can be perceived louder or quieter based on how long it takes for the pressure to reach its maximum. We call that the rise time. And the entire time the aircraft is flying supersonically, it's creating a sonic boom. So you can think of it as the plane dragging a so-called carpet of impulsive sound or sound that's quite short in duration uh, behind the aircraft. And it can be 20 to 50 miles wide, depending on the speed, the trajectory of the airplane, the altitude, and the weather of the day. Um, the sonic boom is not just a one-time thing that happens once you exceed the speed of sound. It's happening the entire flight path that the aircraft's traveling supersonic. So you might perceive the sound at the ground just once as the aircraft flies over you, but if you teleported to the next town over, you would hear the sonic boom again as the plane flies overhead. We care about this because a 50-mile wide carpet across a flight path that can be hundreds or thousands of miles long can potentially be heard by millions of people. And this noise can be heard in areas that are not used to hearing sounds, like maybe remote areas. They're not typically associated with aviation or transportation noise. So if the prohibition on supersonic flight is lifted, it's going to be important to make sure that the sonic booms are as quiet as possible. And for the NASA Quest mission, we're trying to find out at what point people start to become bothered by quiet supersonic overflights. Different portions of the flight can create different types of sounds. Here's a diagram of a typical supersonic flight. You fly up to your cruise altitude, you cruise, and you slow down and descend. So when the aircraft is accelerating to its cruise speed, oh, I got muted for a second. Sorry about that. Can you still hear me?
Yes.
Okay, great. Sorry about that. Uh, so the aircraft starts to accelerate to its cruise speed, and the sound from during that acceleration can get focused, and it's kind of like light rays passing through a magnifying glass. That focused sound can be much louder than the rest of the flight, but it happens only in a pretty small area. Additionally, the atmosphere can bend the trajectory of the sound or change its direction, and we call this refraction. Sound that initially travels downwards forms the so-called primary boom carpet, and sound that initially travels upwards but bends back around and reaches the ground, we call that the secondary boom carpet. And it typically has a more rumbly character rather than an N wave shape. Sonic booms are quite bass heavy, so they can be audible even if you're indoors with your windows shut. They might rattle things on your shelves, and they arrive pretty much without warning, unlike subsonic aircraft that you can hear coming for several seconds as it flies overhead and passes by, building to its peak loudness. But that being said, it's possible to reduce sonic boom loudness. The aircraft can be cleverly designed so that the N wave shape doesn't happen, and instead it has a more sinusoidal shape that's much quieter to the human ear. How exactly does this work? It turns out you can design the plane in such a way that the complicated shock structure near the aircraft partially cancels itself out or is cleverly absorbed by the air in the atmosphere as it moves between the aircraft and the ground. And then shown on the bottom here is the loudness of different sounds on a special decibel scale that we use called the Stevens Mark 7 Perceived Level of Loudness, or PL. It's not the same as other decibel quantities that you might have heard of, even though it uses dB. It's the perceived level of loudness in decibels, and so this red value, or this red text here shows the loudness of the Concorde sonic boom, which is an N wave, and it's about 105 decibels, which is like loud thunder right near your head, or a balloon popping. But the X59 is being designed to produce a shaped sonic boom or a sonic thump of about 75 decibels, which is much quieter. And we anticipate that it'll sound similar to distant thunder or your next door neighbor slamming the door of their car. So here's a schematic of the X59. It's going to be used as the noise source for the community noise surveys. It's about 100 feet long. It's going to fly at 1.4 times the speed of sound, and it'll fly about 20,000 feet higher than your typical airline flight. It only has one seat for the pilot because its goal isn't to be a supersonic transport, but instead it's the noise source for the community noise surveys that are going to help determine how loud sonic booms can be without becoming too bothersome. Another cool feature is it doesn't have a forward-facing window because the nose is so long and pointy, and it instead uses a camera system that the pilot can see on a screen. He can see where he's going on a screen in the cockpit. So the long dart-like shape of the body is able to reduce the sound of the sonic boom from a boom to a thump. Here are a couple images of the airplane being built. You can sort of get a sense of the scale here with the people standing on the delta wing. The airplane's powered by an existing fighter aircraft engine, and it recently underwent structural testing in Texas, but now it's back in California for the final finishing touches. It just got a new paint job, and the target for its first flight is later this year. Again, the Quests mission phase are shown here. Its goal is to collect community noise survey data on people's reactions and perceptions of low noise supersonic flight. The mission's divided into 3 phases. Phase 1 is aircraft development of the X-59. It's currently underway. Lockheed Martin is leading the build in Palmdale, California. And phase 1 includes the design, fabrication, and the ground tests of the X-59. Then when it's ready, the aircraft will do a series of flight tests to prove that the airplane's ready and safe to fly. After that, we'll conduct the acoustic validation, which is phase 2. Here we'll be proving that the acoustic signature of the airplane matches what we set out to design, and we'll conduct detailed in-flight and ground measurements of the airplane's acoustic signature in preparation for our community testing. That's phase 3. That's the execution of the community response tests and the data analysis. That phase is going to consist of several month-long flight tests over different communities in the US and possibly abroad. NASA's been preparing for the Quest mission by building up the complexity of testing, which is good engineering practice. We started out in our lab spaces where we have a lot of control over the environment and the things people hear. Then we performed a small community test where we asked people to rate their perception of sonic booms in order to test our survey methodologies in a slightly more complex environment. And then after that, we went to an even larger community so that we could learn even more lessons before the X-59 flies over communities over an even larger area as part of phase 3 of the Quest mission. So how do we measure people's perception of the sounds? We'll fly the X-59 over 5 communities across the US, each for about a month with up to 6 overflights per day. And at each location, about 1,000 people are going to be recruited to respond to a survey on a phone app or on the web where they're asked to rate their annoyance to each of the overflights. Then the community will also be instrumented with noise sensors to measure the loudness of each of the overflights. And after that, we can link the loudness of the sounds to the annoyance that people report. This data will help regulators decide on the loudness that supersonic aircraft can be in the future. Here we have the type of data that will be supplied to the regulators to help them decide what noise limits to place on supersonic aircraft. We have the perceived level of loudness on the x-axis, and then the percent of people who reported that they were highly annoyed on the y-axis here from 2 different previous NASA flight tests. The X-59's design target is 75 decibels, so we anticipate seeing very few reports of high annoyance at that level. And during the community tests, we'll vary the noise level around that 75 dB point to create data plots similar to this one, which we'll then supply to the regulators. So, in summary here, the X-59s will soon be flying over the US to gather data on people's reaction to quiet supersonic flights. The data will be provided to regulators so they can decide if the current speed limit can be changed to a noise limit. We're still in the planning stages, but things are getting close and coming up quickly. So I really appreciate your attention. Be sure to check out the internship website and apply. And thanks so much for listening, and I can take any questions.
First of all, Will, I just wanted to say that was amazing. I love how you highlighted you came from humble beginnings, scooping ice cream and fixing paintball guns and having the hustle of selling them. So I really appreciate you sharing that. And I hope some of our students on here or our adults can, relate to that and see how the passion starts young. Um,
Yeah,
I
for sure.
I want to see if anyone has questions that they would like to ask via chat. If you want to stop sharing screen, I think the chat box will pop back up.
Okay.
Maybe it should. Right, so I'm just gonna, okay, we have a question coming in. Will community participants be notified of each boom through the app, or is them not responding a response in itself to show that the boom was not too loud?
Yeah, we'll be reminding people periodically to respond to the survey. We found we in our control tests, we did sort of A/B testing where we had some people receiving reminders to fill out the survey and others not, and found that the reminder group had higher prevalence of responses. So that's really important to make sure we can gather data that's not or that's spanning the whole noise range rather than the no reminder group, which tended to respond more often to louder booms.
Awesome. Yeah, I know in our eCYBERMISSION, our mission folders, our students, we have a lot of discussions about analyzing data and making sure we have a good sample size to go off of and pay attention to all the variables. So I like that you talked about that.
Oh yeah, for
Um,
sure.
so our next question, actually, this is a really good question I wanted the answer to. If you were a passenger, would the supersonic flight feel different than a regular flight?
Yeah, this is a good question. I had the same one. I had to ask the NASA test pilots when I first started, and they told me that no, you don't hear the sonic boom in the cockpit, and no, you don't really feel any different. You're just moving faster. Maybe depending on the airplane, once you're approaching the speed of sound, the control of the airplane changes a little bit, so they try to pass through that quickly and keep their speed up. But no, it doesn't feel much different than a regular flight.
Awesome, thanks. I maybe I could handle that if I could get to my distance in half the time. I
Oh
could.
yeah.
Yeah, I think that would be nice. All right, so how long does each boom last from the perspective of a person on the ground since the plane is going so fast?
That's a good question too. That it's about 100 milliseconds, so it's very brief. It's like a boom boom and it's done. And you can sort of hear it reflecting off different surfaces. You can hear it reflecting off the terrain and buildings, and so you can hear like a little bit of a low rumble afterwards, but the main event is done in about a tenth of a second, maybe a little longer, depending on how long the airplane is.
And I have a question. So I know that as someone who loves to travel, I would love to go somewhere in half the time. Is this something that if like like the prohibition got lifted, that would be affordable in the future? Is that the goal, or is this just like for the upper echelon celebrities?
Yeah, definitely. It's the goal is to make it affordable for regular commercial flight. Right now, it starts out, more expensive and it'll be more of a business class experience, but we're hopeful that as the technology improves and the time savings are so great that it can come for regular, everyday people as well.
Awesome, thanks. Does anyone else have any questions? Please feel free to unmute yourself. You could drop it in the chat. Give them a second before I have just a couple quick questions for you, just that I want to have our students hear some of your feedback on.
Sure. Yeah, great question so far.
You have one more. Does the weather conditions affect the impact of the sonic boom?
Yeah, actually, a great deal. So the prevailing winds can change the size of the region that's exposed to sound. It can, if you have like a tailwind, the sound region is usually a little bit bigger than if you have a headwind, for example. And the temperature of the air changes the speed of sound in a profile from the aircraft to the ground. And so the sound is coming down, and if it's hot on the ground, the acoustic rays can bend up, and actually there are conditions where a sonic boom doesn't arrive at the ground, and that's called Mach cutoff flight, and there's some interest in that where you can fly like Mach 1.1 and maybe the sound won't reach the ground. So yeah, the weather makes a big difference, and um, even depending on the humidity of the air, it can change the way that the sound is absorbed. So sometimes different regions of the country can experience greater or lesser loudness based on how much humidity is in the air.
Awesome, thank you. I wouldn't have even thought of that question. Looks like we have one more. What advice do you have for a student who wants to work for NASA?
Great question. Yeah. I would say follow your passion and your dreams. Learn as much as you can. Get in. I mean, I loved learning about computer programming. Um, I would say try to go after those internship opportunities and those research opportunities when you can. Keep your grades up, of course. That'll help. Uh, but yeah, I would say just go for it. If you want it, I'm sure NASA is going to want you to.
Thanks. I like that encouragement for our students too. I think that's super important. I'm going to give just one more minute to make sure we don't have any other questions trickling in. In the meantime, I did want to ask you, so you sounds like you had a pretty broad spectrum of interests. Do you think in the future you'll continue to want to work in this field? Do you see yourself wanting to, grow within NASA or like, go back to computer programming or any of that?
Yeah, NASA's a really good place to work. I see myself staying with this project as long as they'll have me. Um,
No, I know.
so
I put you on the spot. I really just it's cool to see the progression of how everything, you can find out kind of your groove and try different things and figure out what you like.
yeah, I was bouncing around, especially in college. It was like I was taking the opportunities that were sort of presented to me. I understand, you can learn a lot, even if it's not exactly your passion, maybe. You can learning those lab skills and those research skills are really important to move you towards your ultimate goals.
So what I hear is even if you don't like math, pay attention in math class.
Exactly. Yeah, and we have I mean, that's one of the great things about computer programming now is the computer can do a lot of the math for you, and you just have to know how to tell it what you need.
We have a question. Oh, this is good. Will airport runways have to be longer?
Um, that's a good question. I
Yeah.
guess it would depend on the design of the airplane. The X-59 itself, it does require, I think, about a 10,000-foot runway, which is it's on the top end. But I'm not sure it'll be,
TBD.
I guess,
TBD.
yeah, that much longer.
So it looks like we don't have any more questions, but I would like to in tonight with asking you for advice for our students. So our students complete a mission folder, which is a community project, needs to have benefit to the community using a certain path. Um, I want to know, like, what advice do you have for these students while they're completing their research or building their prototype or conducting an experiment? What do you have for them just to be fruitful in that?
I think a lot of what I've learned is to ask for feedback early and often, and that'll help you get a better end product. So you can, you don't want to silo yourself. You might think you know exactly what to do, but if you present your research and your tasks early to your mentors and gather feedback, that'll help you achieve an even better product in the end.
Well, thank you so much for your time. It was truly informative, but also inspirational. And I'm loved that you gave a shout out to the ice cream shop owners as well. That was hilarious.
Yeah,
But
they're great.
I want to thank you for your time. I want to thank everyone who attended today. And if you guys have any additional questions, please feel free to email me or use our message board. You can get in touch with our other cyber guides. All right. Thank you so much, guys. Have a good night.
Thank you. Appreciate it.